How many prime numbers are there? Infinitely many. So recall that an integer n is prime if its only factors are 1 and n. Examples include 2, 3, 5, 7, 11, and so on. Here we're going to show that there are infinitely many primes. Now to do this, we're going to construct a proof by contradiction. Assume that there is a largest prime, let's call it p. And here we'll examine the number p factorial plus 1. Now p factorial plus 1 has no factors between 2 and p. Another way of saying this is that p factorial plus 1 is congruent to 1 mod m for all m from 2 to p. In other words, if you take p factorial plus 1 and divide it by any number between 2 and p, you'll have a remainder of 1 left over. For example, consider 5 factorial plus 1, which is 121. It's not divisible by 5, 4, 3, or 2. Instead, it's 11 squared. So this means that if we factor p factorial plus 1, its smallest prime factor must be greater than p, which means that p is not the largest prime, which is a contradiction. The fact that p was the largest prime was our initial assumption, but it turns out that that assumption disproves itself. So therefore, there is no largest prime. Instead, there are infinitely many primes, and the largest known prime today is 2 to the 43 million and change minus 1, which is about 13 million digits long.